Okay, hello people. So in this video we'll continue talking about C++ and learning about C++ threads. I will be following the book C++ Concurrency in Action by, I don't remember the name of the author, but it doesn't really matter. And yeah, I have 1 hour and I will try to learn as much as I can. And if you're interested, please follow along with me. I hope it's gonna be fun. And yeah, for the last time we left off by covering the transferring the ownership between different threads, right? For example, the same technique can be applied when you create a unique pointer. You cannot move, you cannot copy or you cannot copy unique pointers, right? You can only move the ownership. The same can be done for std thread. Basically, when you create a thread, the thread starts its execution and then you can move the ownership. But yeah, let's write some code. Okay, so that was the block of code that we wrote for the last time, and we created a couple of functions. So let me actually put the white space here so it's clear that we have two lambda functions here. So we have the first one and the second one, and we create an instance of an std thread, and we assign this function for the thread to execute. And then what we do, this is basically an std move, but sometimes I can do it. I don't know why, but usually you should be using std move. And then we move the ownership to t1, right? And then in t0 we create a different instance of the thread and move the ownership to t0, and then we create t2, which is just default constructed. It doesn't have any tasks assigned to it. And yeah, actually this threads in C++ is a little bit hard because I mean, in comparison with Windows 32 API, where everything is explicit, but yeah, I think that's just me not being comfortable with std thread. But anyway, and we later move the ownership of t1 to t2, and right now t1 executes the first function, and thus t2 will execute this function, right? And then we join them. So t2 executes the first, t0 executes the second function, and then we join those two threads. But if we had previously like this, join shouldn't probably be here, right? So we had this code previously, and what we are trying to do is we were trying to move the ownership from t2 thread to t0, and that's not allowed because t0 has already the function assigned to it for to execute, right? So we won't be able to join t0 because we just moving the ownership of t2 into t0, and yeah, we will basically get the program will terminate. And here it comes inside the. Okay, so it tries to. Yes. Okay, so that's exactly what happens here. I hope you understand. So what we are trying to do is we are trying to move the ownership from t2 to t0, and what happens is that we check on the t0 whether the thread is joinable, and it is. And if it is joinable, then we terminate the program, right? And the assertion actually comes from here, not from this line. We can even put a breakpoint here to make sure. I don't know whether we'll hit it or not, but we can, yeah. And then we assert. And I can even do step by step, so to make sure that we do understand everything and me in the first place. So we're trying to move the ownership. We step inside the if we can check this, It should have some procedure assigned to it, but yeah. And because the thread is joinable, we just terminate the program. All right. Well, that's actually copy assignment as well. Move assignment as well, right? No. I think it's regular. Okay. Yep. And let me take a look. So we are calling it here. We move in the object. And here we do the same, but I'm trying to understand what's the difference between when we are moving here and when we are moving here. So because it's a temporary, right? We assign the second function and then we move the ownership to T0. And thus it will be no longer executing the first function, it will be executing the second function. And then we create an instance of T2, default constructed, and move the ownership of T1, which... okay, now I understand. The reason why we can move here is because we moved here. If I comment out this line, that's at least my understanding, we will experience the same situation that we have in this line, right? Because T0 has already a function assigned to it, we cannot move to this object. Let's double check. Let's put a breakpoint, and first I have to remove the breakpoint from this line. So we create an instance, we moving, and yes, exactly. It checks whether the thread is joinable, and it is, and then we terminate. Okay. So just a quick recap, maybe not quick, maybe it goes too long, I don't know. I'm just trying to understand how it works in general, so then I can apply the knowledge and write multi-threaded applications. But that was, or at least supposed to be a recap of what we have done on the last episode. But let's continue. I don't exactly remember where we left off. Yes, okay. Probably I have to mark somehow. Okay, yeah, so that's what we did. And here is an explanation. The final move transfers ownership of the thread running some function back to T1, and don't pay attention to namings because I'm starting indexing from 0, whereas the author starts indexing from 1. But in this case, T1 already had an associated thread which was running some other function. Exactly, so std terminate is called to terminate the program, because I showed you since the thread can be joined, right? This is done for consistency with the std thread destructor. Explicitly wait for a thread to complete or detach. Means that ownership can readily be transferred out of a function as shown in the following listing. So we create a couple of functions and we just move in the ownership out of a function. If the ownership has to be transferred into a function, it can just accept an instance of std thread by value as one of the parameters. Okay, what we can do, maybe I can even mark episode 3. or it's like, I don't even know how to spell the word. Okay, so I'm just I have to think whether it's the second one or the third one. Since I'm starting indexing from 0, okay, it's gonna be third one. And I will create a block so we can experiment, right? I will create a lambda function. Accept thread, and what it does is takes thread and does something in thread itself. And maybe it can accept the function as well. For example, no, let's make it simple. What we can do is create like a thread t, and we can accept thread, and we can pass t, but we have to move it, right? You would have to move it. Yes, okay, and inside we have to t join, because if we call it's not actually t, it's thread, right? If we call obviously we cannot call t join here because that won't work. The t object is no longer valid, right? I mean, we can try doing that, but I just kind of trying to warn you that it will never work that way, because the ownership was moved, and it was left, the t was left in well, it's not a dangling reference, but the behavior would be undefined if you're trying to we join the thread. Okay, what happened? I wonder what happened. The thread is not joinable. System error memory location. That's interesting. So since we are moving, maybe we have to assign like a procedure. Running on separate thread. Will it work? Yeah, okay. Because it was default constructed. But I hope if we do this, okay, I don't know, I have to take a look at this thread class itself. So we have a default constructor, that's the public member. The destructor, the move constructor, move assignment operator, and then copy and copy assignment both are deleted. Then we can swap the threads, and that's pretty much it, right? We don't have anything other than that. I wonder how do we create a thread? Do we invoke like in the Windows 32 API create thread function, and then we run that somehow? Okay, so that's the function start. Invoke. Yeah, I will put a breakpoint here. Oh, here is another constructor. So we provide a function and some additional arguments, and that's where, yeah, and exactly the execution starts, right? But if we don't provide anything, we will invoke this constructor here. And then forward, okay, we forward it to make it unique here, then get invoke, make index sequence. Okay, I hope this does the trick, like the begin thread, the begin thread EX procedure. I don't know where does it come from, but I assume that's from Windows 32 API. It's a process.h. Okay. So that's actually the function which runs the thread, and that's how we start the execution, right? Because whenever we create a function, so let's assume we created an instance of an std thread, we provided a function, and the function can be either R value reference or L value reference, I think, because that's I don't know. And then all the arguments, we forward the arguments to the start procedure, and we forward the function itself, and then we invoke. And this is actually the place where we start the thread, right? This place. Okay. And then we can come back. Okay. And then when we join in the thread, we invoke transition. Okay. Well, at least now I understand more. So that's always better. That's always better. I think we can try and write in our own thread. I just let me take a look at the create thread procedure Win32 API. Okay, so we will grab this. We'll use it for the future. What we'll try to do is we'll try to create our own thread, and we use this under the hood, right? But maybe I will dedicate a separate video, and in this I will try to go through the book itself. Okay, so let's continue. If the ownership should be transferred to a function, can be just accept an instance of std thread, and that's right, that's exactly what we did here. And then we don't need to call join because we already joined the thread in this function, right? Yeah, let's step through it to make sure that, I mean, I do understand everything, but I hope it's going to be helpful for you as well. And I have to put a breakpoint inside the move constructor. Okay, so we invoking that, and that comes from this. Yeah, exactly. We invoke the move constructor. Yeah, okay, that's fun and fine as well. Cool. One benefit of the move support of a thread is that you can build on the thread guard class from List 2.3 and have it actually take ownership of the thread. This avoids any unpleasant consequences should the thread guard object outlive the thread it was referencing. And this also means that no one else can join or detach the thread once ownership has been transferred into the object, because this would primarily be aimed at ensuring threads are completed before a scope is exited. The implementation, okay. Yeah, we can try doing it as well. So I will create a structure, not a class, because I'm not a big fan of classes. Thread scope, thread scope or whatever, and what we can do, so we have thread here, and then we have a constructor which takes the thread itself, and then what it does is remove this, and what we have to do is we have to check whether the thread is joinable. If the thread is joinable, if not joinable, then we throw std user. Do we have such an error? It's like a runtime error. Logic error. Okay. The thread has already been joined. The thread with ID. How do we compute an ID? Okay, we'll go through it later, but the thread with ID has already been joined. So what happens in this situation is we move the thread, but the thread itself has already been joined before we moved the ownership, and thus when we invoke the destructor, the idea is to just join the thread. And if we don't check it here in the construction, right, that the thread is joinable or not, we'll try to join the thread or detach. Yeah, but usually detach is not a good practice, and we fail. We terminate the program, which comes from the destructor of the thread itself, right? And what we have to do here is we have to remove copy constructor. Oops, what do I do? What did I do? Okay. And we can do it like this. Delete it and thread scope operator equal const thread scope, and that would be deleted as well, right? Those things will be deleted, which is correct. And here maybe we can create a buffer like a std or string stream, and probably we have to include the header. I don't know where's defined. Let me Google std or string stream. Where does it come from? Okay. Ss stream. Okay, so that's the header file that we need. Ss stream. That's correct. That's correct. Okay. And then what we do is the thread with ID has already been joined. We copy this message, we put it here, the thread with ID, this ID, and the thread, do we have some get ID? Okay, get ID has already been joined, and what we do here, I assume it accepts takes a string, so we have to take a look. Okay, extract the string itself, and here what we can write is std or string stream, string stream, joining the thread with ID, and that's gonna be, and let me retrieve an ID, get ID, and yeah, or rather the thread with ID with this ID has been joined, right? Has been joined. Was joined. Okay. So that's gonna be our message, and I will put it here, or as obviously I could have written it. Well, we can't even do this, right? We don't even need to bother with having string stream. Okay, and then we join the thread, and we have to mark it explicit, so to prevent implicit conversion, since we have only one argument, right? And for those people who are fans of classes, I can mark it as class, and then that would be the private field somewhere in the bottom, and all the rest of the methods will be here. Okay, so that's what we can do, like a simple straightforward class, which helps us to manage the threads. And now what we can do is std so that's gonna be episode 3. std thread, we create a thread, and probably we have to assign some kind of a procedure, and then what we do, oh, you know, we can even do this, thread scope, and we can create the thread directly and provide the lambda. Shouldn't take anything, should provide a lambda. Maybe the lambda takes like an integer, integer to the t, and ID, and maybe takes a string as a message. And then what we can do, we can Okay, so it's getting a little bit out of control, but the thread, we provide a lambda, that's the body of the lambda. Running the thread ID, well, it's not actual thread ID, but nevertheless ID and message, and what we do is ID. I always forget that this is actually not a printf, it doesn't support formatting, so I have to do it like this, and message. Okay, and that's not correct for now, so we'll have to pass to the creation of the thread itself some ID 1 2 3 4 5, and I don't know, hello from thread. That's going to be our message, and then we have the thread protection, thread scope. No, we should explicitly convert, no? Yes, we should do that. So what's the problem here? Declared is inaccessible. Did I make it private? Yes, I did. That's actually the reason why I prefer doing everything with structs, especially when I'm learning things, because it's way more easier. But anyway, I will try to develop like a good habit and make everything with classes for the purpose of learning. A local variable with no name. I mean, it should be fine, right? So we remove the breakpoint, and what we do here is we move the ownership, and then we check whether the thread is joinable or not, and if it isn't joinable, everything is fine, and then we get to the constructor. We print a message running on a separate thread, but I have no idea why we are actually not printing the ID. That's running. Okay, so that was a different message. Yeah, we should have printed the message. The thread with ID. Running the thread. Okay, since I don't have std handle here, so that's an actual message. Okay, that's strange. I will print std handle and try again. Running on a separate thread, right? Viz ID 5. Okay, was joined. The thread with ID, this ID was joined, running the thread. I did this, and it's not actually ID, it's some kind of a parameters that we pass to the thread, and they function. That would be our message. Can we retrieve the ID inside the thread? The procedure itself. I don't know. Get ID. std thread get id. This thread. Okay, so what we can do, Google knows everything, get id, and that would be the message, and we don't even need to pass anything. So instead of doing id, we just get set, and we don't need to pass an integer. And here is our lovely message. And as you can see, the ID is exactly the same, right? Std this thread get ID retrieves an ID of the current thread. And I wonder how it works in like under the hood. So if we create a thread, and maybe we can do it in a separate scope. So for example, we have scope for this, so the destructor will be invoked here, but then somewhere down below we can create a different thread, and t0, and we can assign some procedure. We can assign some procedure, foo, whatever. I just want to see how do we get ID, the thread ID. Okay, so it's only function. Can we go to the implementation? Thread ID. Yeah, and I assume it comes from a different file. But okay. This thread ID and get ID. And I will have to join t0 join to make sure that we wait for the thread to finish, and then I specify the full function. And I will put a breakpoint here. Okay, yeah, I cannot step inside, unfortunately. But that's fun. Fun. By always saying fun. So let's continue. Yeah, we join the thread and then we pass into the function. To that from listener key. Okay, rather than having to create a separate named variable for it. Okay, so that's, I think, is important. When the initial thread reaches the end of f, the scope thread object is destroyed and then joins with 3 here inside the destructor to the constructor. Whereas with the thread guard class, we have to pass it by reference. What we can do instead is I can do this. I can create a thread. Okay, let me even do this. I will not join it here, right? I can only create an instance. So create an instance of std thread class and start executing this function on t0 thread. But then I will create a thread scope and I will move the ownership, but before I will do the joining. I will do the joining before. So I will put a breakpoint. So I join the thread, then we check the thread is not joinable. It has already been joined before. We do the message, and here is logical error. The memory location. I'm wondering why we are not printing the error itself. Probably we should. Can we do this? It inherits from an exception. Okay, let's specify here as well, but so I can see the message at least. Yep. The thread with ID 0 has already been joined, and that's probably the reason. I wonder why I cannot. Oh, maybe it returns a different value. Illegal use of namespace identifier expression. Identifying expression. Okay. But you got an idea. And it's complaining about don't try to declare a local variable with no names. Okay. Yeah, and here the author is trying to compare the implementation of when we pass this thread to the constructor by reference, and when we do the same with moving the ownership. Yeah, okay, so we can create a vector of threads and then iterate through all of them, and then we push back the thread, which means we move in the ownership and then iterate that. Yeah, that's cool. That's cool. So I will comment out this line because we don't want to join the thread. So what we can do, vector of std thread, and the thread pool. Well, it's not really a thread pool, but if I declare this, it'll create me like a no, just yeah, okay, never mind. It will call the oops, that's not what I wanted. Yeah, okay, so here is an explicit. So it will try to create an instance of std thread out of 5. And let me actually try and see what happens. Okay. Yeah, we specified the size, but that's fine. So now I have to create a loop. And thread index equals 0 and thread index less than thread pool size and plus plus thread index. And what we do is we take, okay, we have a thread pool and push back, and we create the new thread. Maybe we can provide a lambda, right? We will not be passing anything. Okay, index, maybe we can pass an index. Global thread index inside vector. And we print an index std handle, and that's fine. And we specify the thread index as well, right? And then we push all of them, and definitely we are not joining, so we have to wow. Wow. Let's stall for a second the program. That's okay, that's not what I wanted. Definitely. We created like a... Yeah, let's put a breakpoint and see what happens. The size is 5. Oh, right, and then when I push back, I just increase the size, right? That makes sense. By saying that, I just created explicitly, I created 5 threads. What we can do, and what we have to do, we have to say, okay, example 5. Yeah, okay, and we are trying to join the thread, and we are unsuccessful, and I can even thread pool reserve, thread pool reserve, and reserve of maybe, I don't know, maybe 7 would be the better. And here we specify the 7, and I can even const expression. No, I don't need really. I just want to specify 7 somewhere, but that's fine. We use it into places. And we have to call for each, and this should come from an algorithm. We have to say, okay, thread pool iterate over each thread, starting from thread pool begin to thread pool end, and invoke f member. What was the function? Std mem function. Std, I have never heard of it. Mem function. Let me just take a look what it does. Mem function. So std mem function. Function template std mem function generates a wrapper objects for pointers to members. Okay, which can store, copy, and invoke a pointer to member. Both references and pointers, including smart pointers, to an object can be used when invoking std-mem. But how do we... Let me take a look at the implementation. Okay. So that's the pointer. And then we invoke somehow the pointer. But that's std thread join void join pointer. No, it's not actually. It should be for this thread, right? Which means maybe it doesn't really matter. It's the thread join. I was thinking maybe it has to be like, but how? Do I have to like to wait a second? Do I have to static cast void pointer? I will do this. Okay, since we are casting from reinterpret cast. No. So we get the address of the function. So here is our join, and it is public. Oh, so that's actually the reason why it's public. That's the reason. Yeah, so that's the function pointer. So what we have to do, yeah, I'm just, forgive me. What we have to do, join pointer would be this. Let me think. Okay, how do I do that? How do I do that? What does it say? A value of type cannot be used to initialize an entity of type void. Oh yeah, because it's a member, right? Std thread and cannot be used to initialize an entity of type void. Takes a thread. Type def join pointer. Do I have to make it like this now? I completely forgot how to do it in C. So here we declare the function pointer join pointer equals why you don't want to cast. Okay, so that's since this is a member, let's see what it takes. Template, that's the pointer. So basically what I'm trying to do is to create a pointer to this function. We obviously can grab an address. And this is public. Okay, what if I do auto? The auto will work. It's just me not being able to deduce the type correctly. Come on, really? I should have done this. Join pointer Now, why do I have to type colon? Well, that's strange. That's strange, I didn't know that actually. And then what we can do is we can create an instance of join pointer. And then it will work, and then we can pass it right here, join pointer, instead of doing it manually, instead of mem function does it for us, we can compute it on our own. I don't know, actually, I hope it's fun. And that's how you build up your knowledge about C++ and C in general. Okay. So we create the join pointer, and it has an address, and if I do this, and they have the same addresses, which is expected, and then we iterate over thread pool, and we call this function for each of them, which is fine, which is exactly what we want. Okay. If the thread's been used to subdivide the work, and let me actually take a look what they print. Yeah, because it's getting interesting. For example, the first, and as you can see, we are passing the indices in the increasing order, starting from 0 to whatever, to 6, right? But we are printing them in completely different order. So for example, the first index 1 gets printed, then index 0, then index 3, 2, 5, 4, and 6, etc. Right? So they are completely in unpredictable order, which is the behavior when you have multiple threads. You create them one by one, and then they started executing tasks. So it's not deterministic. But okay. If the threads have been used to subdivide the work of an algorithm, this is often just what's required before return to the caller. All threads must have finished. Yeah, the simple structure. Yes. Result of the operations. Okay, putting a std thread object in std vector is a step toward automating the management of those threads rather than creating separate variables for those threads and joining with them directly. They can be treated as a group, or fine, thread, group, but I think the author is getting towards, is leaning towards like a thread pool. And it doesn't really matter how you name it, the idea is the same. It's just a group of threads which execute a particular task. Group, thread, group. Okay, choosing the number of threads at runtime. That would be interesting. That helps here is std thread. Hardware concurrency. Let me take a look. This function returns an indication of the number of threads that can truly run concurrently for a given execution of a program. On a multi-core system, it might be the number of CPU cores, for example. This is only a hint, and the function might return 0 if this information is not available, but it can be a useful guide for splitting a task among threads. So yeah, we can do this, and I hope it returns something. Maybe it returns an integer. Let me just Google std thread hardware concurrency. Yes, it returns an unsigned integer. Let me take a look. It's in 1 hour. Well, I don't know, what should I do? Should I like stop and record a couple more videos, or I can just continue and it will be a video for maybe 2 hours, because I want to finish with at least chapter 2, so that would be great. So I assume I will continue. Hardware concurrency, and number of actual threads, thread count, whatever that means, and then we would print that. Number of threads that can be used to execute the program concurrently. Not sure whether whether the spelling is correct for concurrently. Should be. And when we get to this point, I will put a breakpoint. So here we retrieve, and obviously we could have put that into the window, and that's an actual thread count, 36 on my machine. So I can use 36 threads simultaneously, I hope. So for example, why am I even doing that is because I can create like 1,000 threads or 10,000 threads, but it will not make any sense because only 36 of them can be executed concurrently in parallel. And that's why we use this function, std hardware concurrency, and I assume it uses some kind of a Windows 32 API function, and there's a hood, but I cannot, and I don't have like the source. Maybe I can find Windows 32 API threads count. Okay. Get thread times and create processes, and create remote thread, create thread, get current thread ID, get thread description, get priority, resume thread, sleep, define function at thread procedure. So I couldn't. No, I cannot I don't see a function. I was looking at the Windows 32 API. I tried to find a function which will basically do the same, but in a C style. So I couldn't find. Okay, this function returns an indication of the number of threads that can truly run concurrently for a given execution of a program. On a multi-core system, it might be the number of CPU cores, for example. This is only a hint, and the function might return 0 if this information is not available, but can be a useful guide for splitting a task among threads. Parallel version. What we can do, for example, identifying the thread, get ID, the master thread. Okay, we'll get there. But what I can do, for example, is let's just decide dynamically how much threads we want to create, right? So we have, for example, a vector, just a simple task that we can do. It's a vector of threads and a thread group again, and let's just take an input. Std cout number of threads to create, and we don't need unknown, and std2.t number thread count to create equals 0, right? And then what we do is sing, and we can do it even in the while loop. And we can check whether this, for example, this variable is less than this, right? We have less threads than 36, and let's give, for example, some amount of tries. Thread, and what we can do is we can create another variable, tries count equals 5, right? And tries count greater than 0, and we increment tries count, and this should be here. This should be here, and the same threads to create. Well, ideally what we have to do is to, since this is the 0, probably we have to check. We have to do it here. We input the first one, and then if it doesn't satisfy, we continue in the while loop. It has a lot of duplications. Probably we can even remove it from the while loop itself and only have it in the while loop, right? And then what we do is exactly what we did above. We iterate it over the for loop. We created like a thread. And that would be the for loop, thread index, and that would be less than thread count to create, and then we create the thread, we execute it, and then we can even put this into the function, something like above for example, we can make a static function, join all threads. And what we can do is we can pass a vector of std threads, but we can pass a reference thread group, right? We can do that, and we probably mark it as const. And what we have to do is we use std for each. Std for each, we iterate over a thread group begin, and we iterate over thread group end. And what we do is we call this function. We can even retrieve the thing that we did before. We can create a pointer, thread pointer, join thread pointer, and that would be correct. And then join thread pointer, we will assign std thread join. That's all great. Then we grab it and we put it inside member function. So that's how we actually join all threads. And we can even okay, yeah, let it be. I was thinking maybe it would be possible as well to put this into the function, like create threads group. But yeah, we can definitely say join all threads, and then we passing the thread group, right? We can do it as well, but we have to pass a lambda, and lambda can be different, so that's correct. So let's see. Call to object of class type, no match and call operator found. So I assume it's complaining about the thread being constant, right? What if I do this? Signed and unsigned. What was the warning that I had? Okay, so right now it's waiting for the amount of threads that we want okay, so let's specify 55. And we joining right immediately. We're creating 55 threads, but now what we have to do is greater than. Okay, I got it. So I have to do this, and then if it's greater than, we do it again, right? And then we are saying we can print some kind of a message, enter again, something like this. Signed assign mismatch. So here is 55, enter again, 65, some different number, and we can create like 38. And we should exceed the amount of tries that we have, but seems like we don't. Okay, we exceeded, and we created still the number of threads. That's not what I wanted. Bool thread count was set correctly, false. Now let me think about the logic of the workflow. Greater than 0. Well, we can say this equals 0 or less or is greater than this, right? It's a little bit overcomplicated, but so if it equals to 0 and or we specified the size which is greater than the amount of threads that can be executed actually in parallel, or we exceed the amount of tries. Let's maybe remove the amount of tries that we have. It's not needed. Okay. I will do it this way. I'll do it this way, and I will create a boolean thread count was set false, and I will specify that as well, and we check whether this is greater than 0 and this is less than threads count to create. Then we say, okay, thread count to create thread count was set equals true, and then here we only execute if thread was set, and we do this. Only this situation. We will not print any messages if we exceeded the amount of tries, although we could, right? Okay, and then we entered the amount of threads that we want to create. For example, 88, it's too big, too big, too big, and 94 is too big as well, and 97, and then we exceeded the amount of tries that we had. But if not, let's just specify, I don't know how many threads we want to run. Maybe like 10 would be enough. Wait a second. Greater than 0 and less than that was set. That's a bug. Thread actual thread count. That's a bug. So let's specify 15. If we get to the point where we create 15 threads, we execute all of them. And what's interesting here is I want to take a look at the order of execution. Thread index inside vector. Okay, so if the first is correct, then the thread with index 0 is correct, was printed correctly, but then like the thread with index 1 was here. Yeah, so the order of things being printed is completely, like, doesn't make any sense. And sometimes we don't even return to the next line, exactly like in this situation. Okay, so that's, no, never mind. Actually, that was before. So here we specified 15 and then 0, 1, 2, 5, 7. Yeah, that's exactly what's happening when we create threads, and then the last thread is here. Okay, so very simple program. Hope it was fun. Let's see what else we got here. That helps here is std. Okay, this function returns an indication of the number of threads that can truly run concurrently for a given execution of a program. On a multi-core system, it might be the number of CPU cores, for example. This is only a hint, and the function might return 0 if this information is not available, but it can be a useful guide for splitting a task among threads. Shows a simple implementation of a parallel version of std accumulate. std accumulate computes the sum of the given value in it and the elements in the range first last. And the sum and the okay. So let me actually specify it manually. Now let's actually do this. Let's comment out this program so we don't have to wait for an input to come. Why do I have this tab open? It divides the work among the threads with a minimum number of elements per thread in order to avoid the overhead of too many threads. This implementation assumes that none of the operations will throw an exception, even though exceptions are possible. Constructor will throw if it can start a new thread of execution, for example. Handling exceptions in such an algorithm is beyond the scope and will be covered in Chapter 8. So what an std accumulate does, it accepts last, first and last. So let's create like an std array. Does it have an example? Does it have an example how it works? Okay, so they have a sequence of numbers. So that would be the sequence. And yeah, I'm not a big fan of starting with index 1, so I will remove that. And then we have to specify std accumulate. It takes sequence begin and sequence and the initial value, init value equals, let's start from maybe, yeah, let's start from 0 and see. So the accumulate, and then where does it print this? Okay, so it should take an address. No, okay, it returns auto. So actually return value is result, and result. So that would be the result, and result here we print it. And the result would be 45, which I think is exactly what we are trying to search for. Yeah, I already have some sequence, but that's fine. Okay, so let's try to implement std accumulate. Would be interesting. Void accumulate or sum up. It's not actually this, yeah. Well, first of all, it has to be templated. So it has to take an iterator, type name, iterator, so the start, and the type name, the initial value, init, well, okay, type iterator, then we grab this first, then we grab last, and t init value, and then what we have to do is iterate through all of the, and we have to return the t as well. Well, we can t result. Now let's create a for loop first. First doesn't equal last, plus plus first, and init value oops, init value result equals result plus, well, in order for this thing to work, the type should have plus equals operator being overloaded, right? So if it's a struct, some kind of a struct foo, and we have like an integer here, right? I. But in order for this to work, and then we want to call the function sum, average sum up, right? Then what we have to do, and we're saying okay, and we somewhere have like a vector of foo, v foo, right? And then we pass in v foo begin and v foo and some kind of an initial value, right, with 0. And that won't work because foo doesn't have an overloaded operator. So what we have to define is plus equals on a foo, where we take like the instance and we return the result, right? So plus equals and can be even defined inside, right? I don't know whether it makes sense to return something. Probably it can return void, but I don't know. So yeah, that's what I'm talking. That let me remove everything. That this should have an overloaded operator plus equal. But in the implementation, what they do is, okay, what they do is just saying we have an init value, we std move init value. No, we don't need an interface. Plus first, and then we return init value, which requires only the plus defined, which is more common than plus equals. And I will remove accum. I would rename it to accumulate, like accum, which sounds good to me. And it will work the same exactly way as we do here. Accum. We can pass the same sequence, and we can even copy, right? We can even copy, and we can assign the result, and the result would be exactly the same. So that would be my accum. And then we step through the program, the result is exactly the same, but we were moving and assigning at the same time, so probably, yeah, let me put a breakpoint here. Init value 0, okay. No, but that's fine. And what we want to do with threads, we want to parallelize this work. So we want to create a function, and that would be static as well, and probably return t. Let's start with the void. Parallel concurrent concurrent acqueue, and that would be template type name iterator, and then we specify both of them, and then we return the result. Then we pass an iterator, and I hope that's going to be the last thing that I will try to implement before going on a short break, because it's already like 35 minutes. First, and then iterator last, and then init value. So how do we do that? How do we do that? Well, definitely at the end we'll create like a std vector, std thread, thread group. So we have a thread group here, and we will have to do the same. We'll have to iterate through them, and then we have to call join all threads. We'll have to pass a vector like the thread group, and then we'll have to return the result, maybe like an init value. So that's where we join all the threads, and then we have to iterate thread index equals 0 plus thread index, and thread index less than what would be the right thing to put here. So here is we have to, like, right now it currently is unknown, right? We have to figure out how many threads do we want in order. So we have a sequence of elements. What we want to do is we want to create like a couple of threads to speed up the process of computing the sum of the sequence, right? And we have to figure out a way how to do that. So it's probably thread count, thread to create count. I don't know, and yeah, I will have to think about name. Let's just put question marks for now. Max thread count. I will retrieve the maximum thread count. So that's the first thing that I will have to do, and I have to specify like the value, how many elements we want to. Okay, I would put it this way. The sum of how many elements we want to compute on a single thread, right? So the sum of how many of the sum of an elements we want to compute on a single thread. Right. Okay. The sum of n elements we want to. Okay. No, that's not the right. That's not the right command. How many elements we should execute on a single thread or whatever. Okay. Mean number. Okay, so mean elements count executed on a single thread, and let it be like 25 elements executed on a single thread. Right? Then we get the sequence, and let's assume the sequence is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and we can use mathematical notation, but it doesn't really matter. So sigma from I equals 0, n equals 9, and just sum everything up. But okay. So, okay. Thread count, and that would be the name. That's thread count. That's what we'll have to do. We create a vector. So in this sequence, for example, we have less than 25 elements, which means that we have to create only one thread, right? If you, for example, have a sequence of 100 elements, we have to create 4 threads, etc. So the way we do it is by and let me actually make this clear. If thread count is greater than max thread count, what we do is we have to basically clamp it, right, or truncate the value. We can even write a function static void truncate thread count. And we can put here an if statement. Thread count. We can retrieve this max thread count, and oops, what did I do? If thread count greater than maximum thread count, we just set to the maximum, right? And then we return thread count. So that's how we truncate thread count, and that's all good. We could have done it easily, like in the if statement, without no problems. But if you want to use it in the future, that's how we do it. I will comment out this code since we don't need. If you want to reuse this function, might be pretty handy. Okay. So that's the easiest part. The hard part would be how do we decide how many elements we need to put into a single thread. Okay. Let's see. So we have 25, and we don't know the size of the sequence, right? The first, last. Okay, so we have to somehow sequence. Okay, size would be, well, we could have specified like last minus first, but there is a distance which takes first and last. Okay, so then we specify first and last, which pretty much does exactly the same what I did, but anyway, let's use the distance. Sequence size, and then let's just have the usage code. Let's put it 0 for now. And that would be the sequence that I have. Okay, let's start from the beginning. And that's our sequence, and concurrent accum. Let's name it like V would be way more simpler. Begin, V end, and the initial value is going to be, we have to define it, right? Init value equals 0, and we have to pass in init value and result, and then we print the result of concurrent accumulation equals result is the handle, and we have a breakpoint, and we'll have to figure out what do we do here inside this function. Size plus oh well, we can just divide, right? Size by, we can divide by this, and then we know how many threads we want to create. But we have to check, we have to make sure that the size doesn't equal 0. Have to make sure that the size doesn't equal 0. Maybe we can have some sort of an assertion size but can be 0, and if it is 0, then thread count what we do is saying, okay, thread count equals 1 if it is 0. And we can even do it without if statement. Thread count, thread count, 1 thread count. Great, and we can do the same for to check whether the maximum, to check whether we exceed the maximum amount of threads that can be executed in parallel, but that is fine. So how do we compute how many elements exactly, and which elements should be computed on a separate on the thread that we create? So that's the problem. Zero, 1, 2, 3, 4, 5, 6, 7, 6, 7, 8, 9. Okay. We iterate over the thread count. So basically, we have to map thread group pushback to the thread, and we will have to pass something. We will have to pass something. What exactly, I don't know. The thread index we okay. How do we do that? We already have a cum, right? So the function should be cum start and init value, and it returns how do we capture the result itself? Okay, let's you know what we can do? Yeah, forget about this function that we have it here, it doesn't really matter. Let's try doing this. Static accumulate result. Accumulate the result. And we make it template, and that would return void, because we have to capture. How do we capture the result? How do we capture the result? Probably it should take and iterate it to the first and iterate it to the second and then t, and that would be the result. I can mark it even as out result. Std vector t results and then we join the threads, and then we call std accumulate on results begin, and the initial value, I don't know, should we pass init value, and then we return this. Maybe we can even call the accum, okay. Since we are moving, so that would be fine. So we have the vector of results. We iterate through all the threads, and we result and thread count. Thread count, and then sequence. So okay, chunk start, chunk end, and we take it by reference results thread index. So we'll have to compute those chunk start equals something, chunk end equals something, and that would be fine. We accumulate the result. How do we do that? well, that would be easy. Let's just compute for the for the case 0. In this case, we have to pass first, last, and the result index. And let me put a breakpoint here. Identifier not found. C assert. Cum is not a member of std, obviously, because that's the function that we have created. And result identifier not found. So that's not the result. It's results. You have to accumulate all of them. Okay, where doesn't the distance size t? Oh, so that's the distance. We cannot. It's a difference type. Well. What are you complaining about? Yeah, okay, so how do I create a vector of specific size but 0 initialized? Maybe I just don't need the vector, or maybe I do, I don't know. Now we have to compute that, right? Okay. Now that's not how it will work, unfortunately, and maybe, let me think. Do I need to use a structure really? How do I capture the result of all the? So right now we have only a single sequence, right? So we can go without a vector. We can say, okay, we have a result. Result. It has to be the default constructible. because if it's not, then we broke everything. And then, now wait a second. We cannot really do that. We cannot assign the return value. We cannot rely on the return value, right? Because the thread itself will not return any value. Like even though the function returns a value, the thread won't be able. And this has to be done as std_ref, because otherwise it won't work. So that would be std_ref. To results, okay. You know, let's okay, so let's do this. Result, and then, even though that's totally wrong way of doing it, but I will still try to do that. Result, and then we don't need to accumulate. We don't need to accumulate, we just it has to be the vector. Come on, it has to be, should be a solution to this problem. I mean, obviously I can like take a look at this book and what the author does, but it doesn't make any sense, even though I did. And I know that he's using some kind of structure, but possible loss of data. Size, let's, yeah, okay, so let's truncate. That's not the best thing ever. How do I retrieve the value from the distance? What does it return? It returns a difference type. It returns a difference type. Okay, yeah, let's do it. Let's truncate it. The thread count. Let's truncate it. So we're pushing back. We have an accumulation function. No, that's not correct. That would be the correct function. Accumulate result first. We do this. Accumulate result first, last, and stdref results and this thread index. Cannot convert. No. Source type of constructor overload resolution was ambiguous. Okay, so what are you complaining about? Function style cast cannot convert from initializer list to std thread. Maybe it's because of static, shouldn't make a difference. Should make a difference. And that it takes a reference. It takes a reference. Wonder results and the thread count. Thread index and takes a reference. What if I remove this part completely and just try to rely syntax error. Why? I don't understand. There were some warnings, I'm pretty sure, but T, and then we move. Why do we need to create? Okay, so let's create a single one. Accumulate result. That would be the function, and then we pass the first, the last, and that's it. That's because it's templated. Well, I don't understand. Simply don't understand. What am I doing wrong? Could take the source type. C concurrent accum being compiled. Yeah, I don't understand. I don't understand why I cannot create. Why I cannot create a thread. Why I cannot push it back. Thread group. I don't know. Let's create a lambda function and see whether we have the same problem. Because I'm pretty sure that's like because of some because of that I don't know something about std thread and templates, obviously. Accum result first and last. Okay, so now it works. So I wonder what was the difference. Can I do... no, of course I cannot, but... And if I, okay, t out result, okay, let's remove this. And std ref, std ref, and what we do is, okay, we are saying that results thread index. std wasn't expected, that's fine. Yeah, okay, so we have some warnings, but that's not critical. And then we iterate over we join the thread group, and then we accumulate everything what was in the result. Result of concurrent accumulation is 0. So let's put a breakpoint and step inside. So that's the init value. We step inside, we discover the maximum thread count, then elements 25, that's correct. Then the size is 10. Elements, right? Then the thread count is 0. If it's a 0, oh, that's not correct actually. If thread count like this, then thread count equals 1. Okay, I will have to finish with this. Okay. Yeah. Yes, 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 yes. So we move in the ownership. Oh, that's, I know what the reason. Push back. So that's what we have to do. But we should be using indexing because we already know how many elements we have. How many threads we have, right? And then we join everything, and then we return the result, and we print the result. Add it equals 0 because we don't do anything inside the function itself. We don't accumulate any result. Accumulate first, last, and 2 more. Okay. Reduce operator value. Let's just initialize with init value. And then we out result equals that, and then out result minus equals init value. out result. Can we do that? So for example, if init value is equal to 10, then what we do is for every the range, for every single range from first to last, we start accumulation from init value, but actually should be 0, right? And then we subtract the init value as well. Okay, now that's fine. Yeah, 45. That's correct. That's correct. And I'm glad that it's working. STD Advanced. Let me take a look at what STD Advanced does. Increments given iterator by n elements. Okay, so that's helpful. That's helpful. But we can have an else case as well. Yeah, I will take a look so it doesn't take like 3 hours or something. Can we? Yeah, I think we can. We don't need to accumulate. Okay, so out result. Here is out result. And we don't need to pass even an init value because okay, and here we have to create the thread count, right? And that's the reason why I said we don't need to. I hope we don't need to push back because we know the size up front. Nope. Cannot be implicitly captured because no default capture mode has been specified. Obviously, because we tried to capture the last element. 45, that's fine. And we can even probably use our cum function. It returned the result. Yes, we can. So we can get rid of stdaq, and that will still work fine. Let me see. Yes, it is. So how do we compute the blocks? Thread group. Okay. So let's assume we have 3. Let me draw it on paper. It will be much more better for me to understand. We have like, for example, 100 elements in a sequence starting from 0 and finishing with 99, which means that we will get 4 threads. We will get 4 threads, and how do we determine So the first would be last would be for okay. Greater start start chunk and end chunk. So that would be first plus thread index, or it's basically our std advance, right? How many multiplied by elements executed on a single thread and then and element would be start std advance start plus elements executed on a single thread. And we have to check whether what if we have less? What if we have 26? We iterate over okay, now I see. No, that's fine. That's fine. And even though it equals 1, I will put it on top. No, maybe not. And then if we have some more elements left. So for example, we have in the sequence 27 elements, but the minimum number of elements that we compute and that we compute the sum for on a single thread is 25, right? Would be 25, which means that we have still 2 elements left. Or it can be between like 2 and it can be between 2 and 25. It can be between 0 and 24, right? So we have to check here. Or no, we have to create more threads than we want. So this actually not correct. Because we have to create one more. We always want to create one more, not only when we end up being 0. So v plus plus 25. So in this situation, we will create how many 31 threads will be created, but what we'll have to do is we have to create 2 threads. So it's always going to be 1. We add one more thread, right? If there are some elements left, we add one more thread. So 10 plus will be 1. Now that's not really the case. Okay. Doesn't equal to 0. We increment the amount of threads that we have to create. Right, and in this case, if you have 26, it will be 1 plus, and even though if you have only one thread, so let's assume the size is equals to 27, right? As I've talked before. So then we create a single thread, and then we have 2 more elements, we create an additional one. Here, instead, we have to okay. Thread count -1. What the heck is going on? What are you complaining about? So we have the thread count, we assign. Okay, we shouldn't have that parenthesis. And we check to see, okay. Then the start would be that's the last element, right? And that will work for 0 as well. Yeah, we have to compute this index. This will work. This will work without any problems. So the advance and iterator and would be just the last. I know it's a little bit strange, but still it's my solution. So start, okay, iterator and equals start plus how many elements left plus minus start. We can do it. we can compute the distance, but assume it's going to be lost, just that simple. And we can define those iterators here, start and we can set else, otherwise we advance both, and we can even put this here, and we can okay, so the start iterator equals always like this, and the add iterator we can compute, and we have like iterator and okay, and then we're saying okay, so that's how we compute the AND iterator, and we can delete all of that. Phew. So let's go through it. And obviously we have a lot of errors, like for example we've got comma, so that would be start and that would be AND. What are you complaining about? So we cannot initialize for some reason, but std advance 2 elements. So we get an iterator begin, and we advance in for 2 elements. Cannot convert from void. Oh, so it returns me an iterator. That's... wait a second. That's what I need. We'll do the old school. So let's go through it. And the threads count, let's take a look at the thread count. Equals 1, which is exactly what we want. We accumulate the... okay, so let's take a look at the first and the last iterators. So the last is the first element after the end. So we compute the AND, and then we pass it, and then everything works fine. Not great. Not great. Verify. Vector iterators incompatible. What are you complaining about? Result, the thread index, and the thread index multiplied by... so that should be correct. And equals last. Oh. First plus... So that's the first thing that I have to fix. Right? And we can even check... okay. We can grab this. And we can say, okay. Does it equal? If no... if yes, then that's the last. Otherwise, it's first plus thread index. And we don't need any if statements. Can I use std advance? Okay, it shouldn't be the return value. Okay. First, and then we advance that amount of elements. And the AND iterator we can even make it explicit, like advance count like this, advance count first iterate first advance count and last advance count equals this. So that would be, and this thread index equals this value. Okay, so then first and the no. std advance start this count. Okay, and std advance and this count. See whether we have the same error or not. And then we create the thread. Oops. Equals first. Yeah, okay, so that's definitely not correct. Okay. How do we do it? Okay, so we have the start and we have the end. Equals first plus... okay, so let's do it from the beginning. So it's sort of advancing, but yeah. And let's delete all of that, and let's comment out those lines. We have the start iterator, and we have the end. And the last will work in this situation, right? Yes, I just have to make sure that everything compiles. And we get the correct result. And then we introduce the AND iterator. And the AND iterator would be the start iterator plus thread count. No, not a thread count, plus this count. And then here we check if this condition is true. Then what we do is we reassign the AND iterator. Okay, sorry, we have to do it first, probably. And iterator and equals last, else let's see. Okay, and what if we increase the sequence? What if we increase the sequence, for example, to, I don't know, let's create a for loop, right? Would be way more easier. For example, 47 elements and plus plus index, and we push back an element okay. Yeah, so we computed the correct result. I hope it's correct. because we can double check with and we are doing it in parallel, which is super cool. I hope it's not too janky and you understand what I'm trying to make here, how many minutes we have. Okay, so 4 minutes. What I will try to do here is see out computing the sum on accumulating on thread, and I will pass an index, thread index, thread index, right, and we can do it after, maybe before. Okay, now let's do it, handle std handle, and we can even print the result of accumulating on a particular chunks, right? So accumulating on thread, we output the ID of the thread and thread index. That's what we do. So what's wrong here? Because the first should go the function and then the rest. Thread index. Okay. Accumulating on thread 1 and accumulating on thread 0, because we specified 27 elements. Result equals out result. Let's do it again. Okay, so that's interesting. So the result of accumulation on thread 1 was 351, and the result of accumulation on thread 2 was 351, which makes sense. For example, 26 plus no, wait a second. Oh, it's like 25 plus 26. We have 27 elements in total, so it's like 51, which is exactly the same. And if we specify more elements, for example, like 40, okay, so let's create 100 elements. I assume 4 threads should be executed. And yes, we have 4 threads executed in parallel and computing the sum for each chunk. So yeah, I hope it was helpful, and we'll continue. I should take a little break because I'm tired. I couldn't figure out like what the best solution for this problem, but it looks good to me, even though there are a lot of things like the cast that is not that safe. Thank you for watching. I hope it was helpful and you've learned something, and I will continue as a theorist and see you in the next video. Take care.